Hello everyone, thank you for joining us and welcome to the Airflow Design webinar. My name's Stephen Stott and I'm a product specialist at XL Systems along with my esteemed colleague Shelby Hanson. At XL Systems we're driven by the motto of taking complex things and making them simple, which we consider to be the very essence of innovation. Beyond developing and manufacturing the world's most extreme next generation environmental control systems, the Evolution series, we offer an unmatched level of customer resources and technical support in maintaining close connections with numerous industry professionals. We consider it a great privilege to be able to share value, relevant information, while building mutually beneficial business relationships. As you know, for those preparing a grow room, the objective is to best recreate the environment that plants prosper in. However, with the cannabis industry having really only been recently brought into the new age on the legal side, we've come to realize that many people haven't had the opportunity to gain much experience with the intricacies and technologies of growing beyond that point. As such, while obvious factors like sunlight and supplying nutrients are widely recognized as direct contributors to plant health and growth, one key aspect that's often overlooked in the pursuit of a successful yield is a necessity for good airflow design. Therefore, we're going to outline why exactly airflow design is one of the most underrated, underappreciated aspects of a grow room, planning and explaining how our knowledge, expertise, and products can help you achieve perfectly even airflow to protect and improve your crops for superior results. With that clearly laid out, we can now begin to delve into the main points. Traditional methods of air dispersion. There are many different ways to run airflow design, so we'd like to start by first taking a look at what has traditionally been widely implemented to best display the contrast between that and the more advanced solutions. In striving to achieve even airflow, HVAC technicians would traditionally install multiple registers in a room. While not entirely ineffective, this still only localized airflow to those areas. With the system running, it could be felt strongly in certain spots, but would then be barely noticeable as little as 4 feet away. In other words, this method was not really that even and illustrated the need for more effective ducting. When it comes to selecting ducting for a grow space, there are several options. Many growers have chosen to get quoted on hard metal ducting, which is big, bulky, and costly, with an installation process so time-consuming and elaborate that it even requires special permits. There are already multiple parameters and bylaws to deal with when setting up a grow facility in order to get everything past inspection, so opting for hard ducting results in even further setbacks. Then, while hard ducting does allow you to adjust airflow by putting it in as many holes as you want, the process of actually putting in these holes requires buying a hole saw and several different saw blades, then taking the time to drill and cut them all. Altogether, this adds a significant amount of expenses, in addition to the stressful structural engineering efforts necessary to determine how to support hundreds of pounds of ductwork and equipment. Even more crucially, you still have to take pressures and velocities into account to determine the maximum airflow that's pushing back against the system's fan. Since different systems produce different levels, this means doing the math and crunching the numbers to figure out how many and what size holes are needed, which is easier said than done. Otherwise, if not properly determined, when air hits the square surface of hard ducting, a lot more friction is created, causing higher static pressures and leading to a lot of issues with the system itself. With an excess of back pressure building up, the system would end up doing whatever it could to try to shoot the air out as fast as possible, and the fan's ability would become severely limited. As a result of this restricted airflow, the system would freeze, leading to other damaging issues and drastically altering the temperature inside the space. For example, it could potentially be freezing cold at floor level and over 80 degrees above 6 feet, an unacceptable scenario that must be avoided at all costs. The complexities of these factors and their potential risks further demonstrate the need for proper airflow. Despite that, we've still encountered a lot of misconceptions about airflow design from certain individuals, with many claiming it doesn't really even matter that much regardless, as long as the adequate temperature and humidity levels are there. This is an incorrect, flawed assumption, and these people haven't understood the difference that strategic airflow design can make. The importance of strategic airflow design. As the most important thing you can set up inside your grow space, airflow design allows you to better condition and strategically control the air by dictating exact temperature and humidity levels. In mission-critical applications, the more heat and humidity within the space, the more balanced it needs to be. Airflow design ensures regular air turns, which are tremendously important for overall air quality and plant health. In general, traditional HVAC engineers will usually set up a space to have air turns occurring once every 10 to 15 minutes. While this is totally fine for common office spaces or home environments, mission-critical applications should be set up at clean room grade levels, with air turns happening far more frequently. As a rule, we like to design your setup so that the air is turned over as frequently as every 1 to 3 minutes and sent where it needs to be. This concept works effectively within a properly sealed room that acts as a closed-loop system. While it's important to note that some people like to vent in their grow room to bring in additional fresh air, we highly recommend setting up a sealed room and keeping it sealed. This way there's a lot less at play when it comes to impeding outside contaminants. Another benefit of having good airflow design is that the risk of these harmful factors can be further mitigated by integrating inline air filtration and UV purification components. The more airflow you have, the more kicks at the can you're going to have at filtering the air for smell and particulate, while utilizing a germicidal UVC bulb to kill airborne viruses, resulting in much cleaner air overall. With that established, we can now take a more in-depth look at the process of how air actually gets into the room and follow that path with respect to a few different setups. How airflow is created. Once a system is hooked up and turned on, it immediately starts pulling warm air from inside your room through the indoor air handler, which goes into the system through the return. The air then goes past the pre-filter, past the cooling coil, past the secondary coil, and into the blower module, where it is scrubbed by the UV air purifier and reconditioned to be pushed out the supply and dispersed via the ducting. At XL Air Systems, we worked for many years to develop a phenomenal solution for airflow design. Fabric ducting, which distributes air through an equal amount of laser-cut precision holes on both sides. Its innovative design allows us to customize it to suit any room's specific layout. For example, a lot of room configurations will have the fabric ducting running down an aisle or in the middle of the room, with directional dispersion dictated at slight diagonal angles of 4 and 8 o'clock. Basically an upside-down V pointing the air down at 2 angled directions. This helps air hit lower on the walls, with some trickling down and coming back up, and the rest bouncing off the side of the walls, then entering into the canopy in the middle of the room, at least a couple feet above the floor, and circling back up into the rest of the room, ensuring that critically important circulation and air turns are consistently maintained. Fabric ducts are generally run down the middle of the room and cover a 24-foot wide span, with a default 12-foot throw range from each side. This width can be extended if necessary, such as with a plastic nozzle that generates a higher velocity by pushing the air through a tight cone, repelling it about 10 feet before it really starts to disperse. The setup that we predominantly encounter these days is vertical racking, which we recommend taking advantage of due to its extreme customizability, with one fabric duct either going through each rack or supplying levels of racking. There are also alternative setups where fabric ducts are situated along the walls, each engineered for air dispersion on only one side and air meeting nicely in the middle of the canopy. In the case of the container setups, we suggest getting a vertical unit, placing it on a dolly, walking it to the end of the container, and connecting it to the fabric plenum via a 90-degree bend. In addition to the traditional sonic flow when it comes to airflow design, in more customized setups, smaller, evenly spaced micro hole options are available if needed. We often implement micro mesh, which utilizes strips of tiny pinholes that circle 180 degrees around half of the duct, enabling the same amount of airflow so that air essentially rains down into the room with less velocity and aggression. This finer dispersion is ideal for use in areas where not disturbing the space is critical, such as drying and curing rooms. Building on that concept, XL Air Systems' approach to designing drying rooms involves the recommended placement of vertically layered drying racks on different levels of movable carts in the middle of the room, with a 1 or 2 inch gap around the outside perimeter in which to set up sonic airflow. Coming out at 5 o'clock angles, the air flows against the wall first, slightly bouncing off but sticking within 1 or 2 feet of it overall, with the micro mesh fabric ducting causing the air to rain down through the racks. Therefore, regardless of your exact application or stage of production, we have the resources to design the perfect configuration for your setup, with proper equipment in place for airflow dispersion. This is a concept that XL Air Systems has taken to the next level. Next level air dispersion. When it comes to air dispersion, keeping average airflow per square foot relatively identical ensures consistency, which is optimal for both a growing perspective and a business standpoint. Ideally, the desired effect is to get to a point where the airflow can't be felt at all, since it is everywhere equally in constant, complete circulation, because plants are not localized to specific spots. In order for us to better illustrate the concept, we suggest that you try to think about it this way. When you walk into a grow room, the air should be dispersed so evenly that you shouldn't even be able to feel it directly blowing on you anywhere. Creating this effect may sound simple enough, but there's a lot of engineering involved in balancing loads, and it's virtually impossible without proper ducting. At XL Air Systems, we engineer our equipment for airflow design with the mentality of the more evenly the better. As such, fabric ducts run the whole length of the room, effectively acting as a sort of curtain to create perfectly even airflow from one end to the other. When supplying fabric ducts to our customers, we utilize the relevant data to specifically engineer them to each system's CFM, static pressure, and fan curve. The size of the holes is determined by the desired velocity, while the number of holes is determined by how much airflow is going to be passing through. This eliminates grower stress by giving them ducting that's uniquely designed for their setup, thereby offering a lot more environmental control than what they've come to know from traditional methods. That being said, even with these benefits, some of our customers have still opted to use hard ducting in their facilities. That's totally fine, and we're happy to devise a worthwhile airflow plan accordingly. However, we have found with hard ducting, it's not nearly as easy to eliminate a lot of those engineering challenges. For example, when choosing hard ducting over fabric ducting, many of these individuals weren't keeping in mind all of the added construction costs and work required to compensate for this difference, nor the difficulty of the calculations necessary for generating proper CFM, nor the installation time required. All of these factors are eliminated with fabric ducting. From a practical standpoint, it can be deployed quickly and easily set up in a matter of minutes with the included aircraft mounting cable, with very few tools and no expertise. This streamlines the installation process by greatly reducing labor costs and time, removing some of the headaches. With regards to airflow itself, since the system fan and fabric ducting are specifically designed for use together, optimal performance and efficiency are a given. When comparing everyday usage, a major difference between the metal ducting and fabric ducting can be the possibility of condensation forming on metal ducting, due to the temperature differential between your supply air and the room temperature. Without permeating airflow, metal ducting can condensate and create unwanted water droplets falling from the ductwork onto your plants. This can lead to things like mold and mildew forming, which is catastrophic to your crop. Hard ducting also tends to collect a lot of dust and dirt, but since cannabis is a consumable food-grade product, high standards of cleanliness must be maintained. This means that you have to regularly shut down everything in your facility and remove all equipment, plants, and bedding from the room in order to properly clean the metal ducting. The cleaning process can entail renting expensive microbots to crawl around inside, or hiring a company to come in, open up the ducting, and blast all the debris out all over the room, which then has to be thoroughly cleaned up before everything is brought back in. Depending on how many metal ducts you have, this can possibly take weeks, inconveniencing you and severely setting back facility production. In contrast, sanitation concerns are completely mitigated with fabric ducts, and maintaining their cleanliness is much easier. They're constructed with an antimicrobial material and designed with an airflow of 2 CFM, permeating all around them for even temperature, altogether ensuring that no particles can accumulate while rendering the formation of condensation impossible. While these properties help keep fabric ducts relatively clean regardless, thoroughly sterilizing them is a quick and simple process. Made from high-quality polyester, fabric ducts are completely machine washable. This gives you the ability to easily shut down and unhook your ducting, throw it in a washing machine, wash it, clean your room, hang the ducting up to dry, and set it all back up again, all within the same day. Overall, the biggest difference between traditional hard ducting and metal ducting and XL's fabric ducting is the level of intricacy and precision offered by the fabric ducting's design, allowing much greater airflow to be achieved, making it a superior choice for use when growing cannabis. All that being said, even if you don't choose to use our products or opting for a combination of methods, we'd still like to provide you with the adequate knowledge of potential risks to ensure that you're prepared.
Things to watch out for. When setting up a grow room, there are several factors to consider, each with its own obstacles and challenges. There's always the possibility of issues arising in certain scenarios, especially if airflow design is poorly done. As such, we are now going to take a look at some things to watch out for when planning and operating your grow facility and how to best remedy these issues. It really starts with the equipment itself. While some HVAC systems can be quite useful, many are not necessarily so effective. You don't want to end up having to get another system or more fans just to compensate for the shortcomings of inferior equipment. So it's important to make sure that you have equipment that's engineered to your specific room requirements. When it comes to operation, the most common problems that are faced by growers are related to temperature discrepancies and thermal stratification, where large air pockets with different core temperatures remain intact in a vertically layered effect. If the thermostat is reading a completely different number than what the room temperature actually is, many sections of the room will become either much too warm or much too cold. As these hot and cold spots form, plants in certain areas of the room grow larger or smaller than others, even though they are of the same strain, under the same lights, and same level of intensity, which can result in very different crop outcomes. These immeasurable differences render it virtually impossible to conduct a lighting test or nutrient experiment, as there's no way of knowing to which factors the results are to be attributed. Additional issues resulting from varying climate could be the presence of damper areas, leading to mold, or significantly drier areas, leading to insect infestation. All of that being said, of course, hot air does rise naturally as well, but if airflow technology is properly implemented and within the right parameters, there will not be that degree of variation. Similarly, if, for example, outside temperatures are fairly regular, but you find that your room is still starting to get slightly warmer, to the point that your system is seemingly unable to keep up, the first thing you should do is check your thermostat. You want to make sure that it is indeed close enough to the return air and adjust it if necessary, so that it is actually reading the temperature coming back to the system. Once you've checked this, if the issue still persists to the point that the coil itself begins to freeze up a bit, it's important to shut the system off right away to prevent any damage. Once it's off, let it sit for a while until everything thaws. At that point, we suggest placing a fan in front of the thermostat itself to blow air onto it in order to kind of trick it into thinking that the air is of that temperature before turning your system back on. If that still doesn't resolve the issue, we suggest taking a look at your ducting. If you have metal ducting installed, then you may want to add a couple more holes. If you are using fabric ducting, it's important to first make sure that it is fully inflated, with no kinks, cracks, or tears in it, and is able to run along the whole length of the room. Many growers have made the mistake of having it stop around 3 feet from an end wall due to a doorway or some sort of obstruction, but it should be no further than a foot away so that air is reaching all corners. With regard to placement, one of the biggest challenges for growers has been determining how to position their equipment so that the air most effectively gets back to the return of the system. We recommend placing your system right inside your grow space for greater convenience and efficiency. In a room with multiple racking systems, it's best to station the systems in accordance with your heat load in the middle aisleways to supply both the front and back sides of the rack with airflow. Then you can drop a small plenum down from the return just above the racking system so that the return is able to be effectively pulled through the entire racking. The challenge of making sure that air is getting back to the return is where the importance of fan placement comes into play. Some growers make the mistake of just kind of throwing in oscillating fans for the sake of it, pointing them in all different directions. We advise against this because the only thing that they're really doing is pushing the air into one section, where it may end up sitting stagnantly for too long before it can actually escape. This results in stale air and pretty much nullifies any serious airflow efforts. Instead, we recommend strategically setting up non-oscillating fans, one-directional wall fans, and standing fans in a clockwise or counterclockwise formation to push, pull, and spin the air throughout the entire room in a circular path to create a sort of air hurricane effect, directing it through every corner and enabling it to reach its destination. On a similar note, since indoor-grown plants do not naturally experience the constant breeze that helps strengthen outdoor-grown plant stems, some growers have attempted to compensate by implementing oscillating wall fans for excessive airflow. While this can result in a small percentage of healthier plants with strengthened roots in specific areas, the outcome is always inefficient as a whole. Fans should definitely not be in a room for the sole purpose of making plants sway, and overly excessive force from fans that are too close can end up damaging plants. Therefore, the much better way to compensate for the lack of outdoor breeze and achieve full growth potential is to provide an adequate airflow system. Obviously, no two rooms are alike, but by following these tips and planning accordingly, you can avoid detrimental issues in most scenarios, while achieving even airflow throughout the entirety of your grow space. We are aware that everybody has a unique grow room setup, so we're just here to assist however we can. In closing, at Excel Air Systems, we strongly believe that whether someone is an experienced grower or just starting out, and whether they already have one of our systems or not, they should be able to reach out to us and with our help, implement effective airflow design in their facility. If you're in the process of planning, setting up, or upgrading a grow room, please don't hesitate to contact us for a free consultation. We closely collaborate with facility operators who consider specifications, dimensions, layout, lighting, heat loads, and outdoor temperatures, so that we can dial everything in with the certainty that nothing is just a guess. With the knowledge, we prepare a 3D digital rendering to illustrate the airflow plan and bring your vision to life. We work alongside you the whole time and make it our highest priority to remedy airflow issues immediately, in order to ensure complete satisfaction. One of the most integral elements of grow room success, the difference that airflow design makes with crop yield, cannot be underestimated. So we've made it a priority to offer easily scalable products and solutions that are specifically engineered for the cannabis industry. Our Evolution Series system ensures continual air exchange every 1 to 3 minutes, 24 hours a day, and the addition of our UV air purifier and clean air filtration system allows you to easily and consistently leverage air quality. Then, achieving perfectly even airflow is a reality with our fabric ducting. Together, these innovative products not only serve as essential components to the propagation of a bountiful yield, but as testaments to Excel Air Systems' dedication to continual advancement. The bottom line is that we really want to put our expertise toward helping our customers and take pride in providing them with the very best in airflow design because we want everyone to be successful. Right now, though, we want to be respectful of everyone's time, so we'd like to express our sincere appreciation to all of you for your interest and attention. Thank you for giving us the opportunity to share our knowledge of airflow design with you. Please feel free to reach out at your convenience with any questions that you may have, or visit www.excelairsystems.com/snapshot to fill out a snapshot form so that we can gain a better understanding of your situation to help you.